Question A. Consider a family of straight lines L with equation y is mx, where m is a parameter. Each member of L intersects every member of a family of curves C at right angles. So this situation looks like this. There are many lines, and every line intersects curves at right angles. So the situation looks like this. And if we draw a tangent to the curve at a point of intersection, this line with equation y is mx will be also perpendicular to the tangent. And it's not necessary here, but this line is normal to the curve at this point. And the first question, write down an expression for the gradient of L in terms of x and y. 1 mark. We need just gradient of this line, it's m, and it's clear that it's just y over x directly from this equation. The next hand shows that the gradient of C is given by dy over dx is negative x over y. 1 mark. And gradient of the curve is the same as the gradient over tangent, and we know that equation over tangent it's as straight line mx plus c, and this m gradient over tangent is equal to the derivative at the point where it is drawn, or notation for derivative is dy over dx. But here we need in general for every point, or for many points, or just in terms of x and y. So gradient of C, it's gradient over tangent, and it's dy over dx. If it is required at some specific point, you substitute coordinates of a point for x for y. But here we should keep x and y, and it's about what gradient of this tangent. But since this tangent is perpendicular to a given line, and we know when one line is perpendicular to another, its gradient is what? Negative reciprocal of the gradient of the line for which it is perpendicular. So gradient of our tangent is negative 1 over m, where m is gradient of this line, and it becomes negative 1 over y over x, and is negative x over y as required. It's in general in terms of x and y. And the next, by solving the differential equation, this equation shows that the family of curves C has equation x squared plus y squared is k, where k is a parameter, 2 marks. So we need just solve this differential equation, and we can see that we can solve it easily by what? Separating variables. It becomes y dy is negative x dx, and integrating both sides we get what? Y squared over 2 plus constant, but there will be enough, only one constant on the right, is negative x squared over 2 plus constant, and multiplying each term by 2 we get y squared is negative x squared, and move negative x squared to the left, it becomes plus x squared is some another constant k. So we get as required. A family of curves has equation y squared is 4a squared minus 4ax, where a is a positive parameter. A second family of curves has equation y squared is 4b squared plus 4bx, where b is positive parameter. B. Consider the case where a is 2 and b is 1. On the same set of axes, sketch the curves y squared is 16 minus 8x, and y squared is 4 plus 4x. Clearly label each curve and any x-intercepts. You are not required to find the coordinates of any points of intersection, 3 marks. So here y becomes what? Plus minus square root over 16 minus 8x, and here y becomes plus minus square root of 4 plus 4x. And we can see that x-intercept here is what? It's just 2. And since there is minus in front of x squared, it will be what? A graph of square root, but it will be what reflected about y-axis, so it will be directed to the left and to the left. So it's according to plus, and according to minus it will be below, absolutely symmetrical, but below the x-axis. And it's what? Y squared is 16 minus 8x. It's not required here, but let's review how to get the square root of 16 minus 8x from a graph of this function, from the graph of root of x. And if you do factorization, it becomes negative 8x minus 2. Or without factorization, it looks like this. And from usual square root of x, which is what 0, 0, 1, 1, and this the first step is what? A horizontal contraction by factor of 8 with y-axis invariant. So this point 1, 1 becomes 1 over 8, 1. Every point becomes 8 times closer to y-axis, and every point on y-axis remains on the same position. Then, according to this minus, reflection about y-axis, and then horizontal translation 2 units to the right. And you can see we get x-axis intercept at x is 2. So the first step is contraction and then reflection, or reflection then horizontal contraction, and then translation. Because if you start with translation, then you should take into account that axis of symmetry will be not y-axis but axis 2, and you may make mistakes. And if you don't do parentheses, if you don't do a product, you should start with translation. So it will be translation 16 to the left, because plus, so it becomes negative 16, 0. Then horizontal contraction by factor of 8, so this point becomes negative 2, followed by a reflection about y-axis, so this point becomes 2 and it will be directed to the left. Or so here contraction reflection or reflection contraction doesn't matter, but if you do contraction by factor of 8 and followed by reflection or reflection, and then if you say that followed by translation 16 units to the left, it will be mistake, because when you have done contraction, it's like a new coordinate system, and according to the new coordinate system you should translate 2 units, not 16 units, and actually not to the left, not 16 to the left, but 2 to the right finally. So if you represent like this, translation then contraction reflection, or product contraction reflection or reflection contraction, and followed by translation. And for the second curve, you can see that x intercept is -1 and plus in front of x, so it's to the right, something like this, -1 y squared is 4 plus 4x. C. By solving y squared is 4a squared minus 4ax, and y squared is 4b squared plus 4bx. Simultaneously show that these curves intersect at the point M with coordinates a minus b, 2 root over a times b, and n at coordinates a minus b and negative 2 multiplied by root of a times b, 6 marks. So we need just solve this, and you can see that since it's y squared is, we can what just equate the right hand sides, and you can see that it's just what it's just linear equation, and we separate with x to one side, just numbers to the other side. So let's move with x to the right and factor out x, so and 4, so we can factor out, or actually we can divide each term by x, by 4, and it becomes what x a plus b is equal to a squared minus b squared, but a squared minus b squared is what a minus b. A plus b is x a plus b. A plus b is not 0, so we can divide it, and x is a minus b. And then substituting into this or this, it doesn't matter, so it becomes y squared is 4a squared minus 4a, a minus b, which is 4a squared minus 4a squared plus 4ab, and y is plus minus, because y squared, so y will be plus minus it, and 2 root of ab. Hence solutions are points M, a minus b, and plus 2 root of ab, and n is a minus b, negative 2 root of ab as required. D. At point M shows that, so we need at M, shows that the curves y squared is 4a squared minus 4ax and y squared is 4b squared plus 4bx intersect at right angles, 5 marks. So there are two curves, and it is given that they intersect at right angle, and if they intersect at right angle, if we draw two tangents, tangents also must be what? Perpendicular. And we consider this at point M with coordinate a minus b plus 2 root of ab. So to show that the curves intersect at right angle, we can show that tangents are perpendicular, and we know that gradient of a tangent is what? Derivative at the point, and then if we consider gradients of these tangents, we hence will be able to show that tangents are perpendicular, and hence curves also are perpendicular. So we need gradient of a tangent, so we need dy over dx, and odd curves. Y squared is 4a squared minus 4ax, and y squared is 4b squared plus 4bx. And for this, let's differentiate, and it will be what? Implicit differentiation, y squared derivative chain rule, it's 2y dy over dx is equal to its constant, so derivative is 0 minus 4 ray, and hence dy over dx is equal to what? Negative 2 over y, and gradient dy over dx at point M, let it be M1, gradient of the first tangent is negative 2 over y. It's y coordinate of point of intersection, it's 2 root AB. 2 root AB, so it's negative 1 over root AB. And for the second curve, it becomes 2y dy over dx is, again, it's 0, it's 4b, so dy over dx is 2b over y, and dy over dx at point M, let it be M2, becomes what? 2b over sorry, I have lost, it's 2a here, so it's 2a, and dy over dx to b over y, and y it's 2 root of ab, so it's b over root ab, and hence if we consider a product of gradients, it's what? Negative a over root ab times b root ab, you can see it's negative 1, and it implies what? One gradient it's negative reciprocal of another gradient, and hence it implies that what? Tangents are tangents to the curves, tangents to the curves at M are perpendicular hence curves intersect at right angle as required. The next, consider two families of curves f and g. The gradient of f is denoted by f of x, y, and gradient of g is denoted by g of x and y. Each member of f intersects every member of g at an acute angle alpha. It can be shown that g of x, y, g is the gradient of curve capital G, and is equal to f of x, y plus tangent 1 minus f of x, y times tangent. In part E, consider the specific case where f of x, y is negative x over y and alpha is pi over 4. Show that g is y minus x over y plus x, 2 marks. So we just substitute this expression for f, this for alpha, and just calculate the value of g. So g becomes negative x over y plus tangent of pi over 4. It's 1 divided by 1 minus f is what, negative, so plus x over y times 1, and multiplying each term in the numerator and denominator by y, we get what, y minus x, y plus x as required. And the next. Hence, by solving the homogeneous differential equation, this equation of dy over dx is y minus x, y over y plus x. Find the general equation that represents this family of curves G. Give your answer in the form h of x, y is d, where d is a parameter, 9 marks. So we need just solve this differential equation. It is given that it's homogeneous, and it means that, what does it mean? It means that dy over dx is a function of y over x. And if it's not given that it's homogeneous, but you just meet such a differential equation, you should understand that here, if we divide each term by x, we get y over x minus 1, y over x plus 1, and you can see the derivative is a function of y over x, and hence we can solve it using the next substitution. Y is vx, where v is some function of x, so dy over dx is what, product rule, x derivative, it's 1 times just v plus x derivative of v, dv over dx, and substituting, we get that it becomes v plus x dv over dx is v minus 1 v plus 1, and hence it can be solved by separating variables. So move v to the right, we get x dv over dx is v minus 1 v plus 1 minus v, common denominator, v plus 1 v minus 1 minus v squared minus 1 minus 1v, so minus v, yes, correct. So v minus 1 minus v multiplied by v plus 1, so minus v squared minus v, yes, and we can write minus in front, so it becomes v squared plus 1 over v plus 1, yes, it's correct, and it becomes what, v plus 1 over v squared plus 1 dv is dx over x, and this minus here, and integrating both sides. So we need, definitely on the right hand side we can see it's a lamp, it's just directly from the data booklet, and how to integrate the left hand side. If you try to use substitution u here and take u as v squared plus 1, you will see that this plus 1 doesn't disappear, but we can split it into two integrals. So integral v plus 1 over v squared plus 1 dv, it's integral v over v squared plus 1 dv plus integral dv over v squared plus 1, and it's directly arctangent. Formula is given in the data booklet, and if you meet something like this, but if it would be minus, here you can see that there are roots in the denominator, so you can do factors in the denominator, and such integral should be found as what, do partial fractions, and then finally you will get ln. But here you can see that there are no roots in the denominator, so it's directly arctangent. Formula is given in a data booklet, and to solve this v over v squared plus 1, we can use what substitution u, where u is v squared plus 1, and du over dv becomes just 2v, and hence what dv, it's du over 2v, and it becomes v du over 2v and u, and you can see we cancel, and it's just du over u, so it's a half ln of the absolute value of u, but u it's v squared plus 1, and it's definitely always positive, so the absolute value bars not required, so it's ln of v squared plus 1 and plus some constant. So our integral becomes, or actually the left hand side becomes, it's a half of ln of v squared plus 1 and plus integral of z, it's arctangent of v is, and the right hand side it's negative ln of the absolute value of x and plus some constant, and it's required the answer be of the form some function of xy is constant. So we need just move these to the left, and v is what, y over x, so it's y squared over x squared plus 1 plus arctan over y over x plus ln of the absolute value of x is some constant. So we can leave it like this, but in general it can be simplified. If you multiply each term by 2, you get 2 ln of the absolute value here, and you can move to the power of x, and there will be ln plus ln, which is product, and you get ln of y squared plus x squared and plus 2 arctan y over x is equal to some another constant. And the last question, F. Let's check the previous a half arctan plus ln constant, correct. And finally F. By considering limit when alpha tends to pi over 2 of tangent alpha or alpha, shows that for all finite f of xy, limit alpha tends to plus over 2 of g is equal to negative 1 over f. And what is g? G it's our function, this one, f plus tangent 1 minus f times tangent. So let's consider limit of tangent. What is tangent? Tangent is sine over cosine, so it's limit alpha tends to pi over 2 sine alpha over cosine alpha. And if we substitute pi over 2, it becomes sine of pi 1, sine of pi over 2 is 1, cosine is 0, 1 over 0 it's infinity. Notice that it's not indefinite. Indefinite it's when 0 over 0 or infinity over infinity, but here it's definitely infinity, or we say that such limit doesn't exist because it's infinity. And if we consider our expression limit of g when alpha tends to pi over 2, and our g function is what? Oh, actually, it's f plus tangent. It's f plus tangent alpha minus f, 1 minus f, n times 10. Notice that we consider limit with respect to alpha, so variable is alpha here, and f is some parameter like a constant with respect to alpha. And you can see that it becomes, since limit of tangent is infinity, it becomes infinity over infinity, and we know when limit is infinity over infinity or 0 over 0, we can apply L'Hopital's rule, and it says that this limit becomes limit which is equal to derivative of the numerator divided by the derivative of the denominator, and f is constant with respect to alpha, so derivative is 0, and derivative of tangent it's secant squared alpha, and we take derivative with respect to alpha because limit when alpha tends to something, and derivative of the denominator it becomes 1 derivative 0 minus f, it's like constant, and tangent derivative is secant squared alpha, and we can see that secant squared cancels, and we get that its limit alpha tends to pi over 2 of negative 1 over f, but it's constant with respect to alpha, and its limit just negative 1 over f of xy as required. It's correct, but this method is not represented in mark schemes. In mark schemes there are two another methods which may be more easier. If we consider limit of when alpha tends to pi over 2 of tangent, it's what? It's 1 over 0. So if you consider limit of 1 over tangent, hence it will be what? 0 over 1, it will be 0. And if you consider this expression, which expression? F of x, f plus tangent 1 minus f times tangent, and if you divide each term by tangent you get the next. It becomes f over tangent plus 1 and 1 over tangent minus f, and since 1 over tangent its limit it's what? It's 0, it becomes 0 0, so it becomes just negative 1 over f as required. Or we know that tangent is sine over cosine. We can represent tangent as what? Sine over cosine, and multiplying each term by cosine we get what? Cosine alpha times f plus sine and cosine minus f sine, and limit when lambda tends to pi over 2 of sine alpha is just 1, and limit when alpha tends to pi over 2 of cosine it's what? It's 0. So it just becomes 0 0 1 1, so we get negative 1 over f of x y as required. And that's all for this question.